To the next speaker. And this is Linas Jurevic from the Department of Water and Energy in Lithuania. Is it right? Yeah. Welcome. And we're going to hear a presentation on remote sensing and fish spawning habitat in reservoirs. Thank you.
Yeah, good. Okay, so a little bit, sorry for the inconvenience, a little bit about myself. I am a PhD student at Vytautas Magnus University in Lithuania, and this is going to be an introduction about my research that I have carried out. And I thought this conference would be quite interesting to present. So at first, I will go very quickly with the base information about all about my object of the study. So to start with, you know, it's what we discussed before. Optimal operation of the large hydropower plant is opposing tasks because on the one hand, we have energy generation, the grid stabilization, and etc. But on the other side, we have the environment protection and other reservoir user needs. So it's a difficult task. And since it's the Sustainable Hydro Conference, I would like to talk a little bit more about the sustainability side of the things. And to start with, it's going to be about the protection of the environment, about the measures. So what the problem is, I came here from the hydro peaking session, but reservoir has a little bit different ecosystem than the rivers, but still the problems are quite similar. Not per se the stranding of the fish, but all the other, the habitat losses, degradation, and etc. It's there when the water levels changes in the reservoir. As Anna has mentioned, the drawdown areas occurs, that the water surface area changes, and then the littoral slopes are exposed. So we're losing the area for the fish habitats. And that's especially difficult question in the areas in the lowlands, because we have reservoirs that are shallow, and the littoral slopes are really not steep. For example, here in Norway, 0.5 meter of drawdown, it's probably not much, but in Lithuania, the shoreline can move like 100 meters and even more in some places. So it's a big concern. Yes, and this is my subject of the study. It's the reservoir of the Kaunas hydropower plant, which is located in the middle of Lithuania, in my hometown of Kaunas, conveniently. Very quickly, the main properties of the reservoir, it's quite large. It's 63.5 square kilometers, and the volume is 460,000 cubic meters. So it's a large reservoir, but as I mentioned, it's not deep. The average depth is 7.3 meters. And on the reservoir, there is, of course, the hydropower plant. So it's 100 megawatts. It's 4 turbines, 4 Kaplan turbines, and the hydraulic head, it's about 20 meters. And also there's a pump storage power plant, so it has the installed capacity of 900 megawatts. The upper reservoir area is about 300 hectares. The depth is 15.5 meters, and the hydraulic head is from 111 to 93 meters, depending on the water level in the reservoir. And it has 4 turbines as well, and they work in the pump mode, like to pump the water. So as you can imagine, there's pretty large hydropower plants, and they really influence water levels in the reservoir quite a lot. So there are some measures to mitigate the impacts on the environment. And this is just a schematic, but the basic principle is that the water level is limited for the energy production. So from the normal water level during the normal operating regime, 90 centimeters can be taken, and the daily cap of the water level change is 40 centimeters. but during the fish spawning season, it's more restricted, and it's like 20 centimeters of water level change. Then there's a question in my head that there is a lack of knowledge. We don't have really good ways to assess those measures. What's the quantity assessment? I mean, we don't really know where the spawning sites are and how these water level changes actually affect their area. So at first I wanted to use the existing data that it's either the old topography maps before the dams were constructed, or we do have digital elevation model for the bathymetry of the reservoir. But once I started using it, I immediately saw that something doesn't look right. So I needed to double check if it is correct, because the nearshore areas are pretty difficult to survey. The traditional sonars do not really give good measurements when the water level is less than 50 centimeters. The green laser LiDAR would be a really good option, but we don't have it, I think, in Lithuania at all. So what I have done, I just packed my things and went for a little fun field research session. So in those difficult areas, the most reliable way is just manual measurements of the bottom. And the outcome is as expected. The red line symbolizes the digital elevation model, and the black line in the elevation profile symbolizes the actual measured data. And it's clear as day that there was no data basically in the digital elevation model. They just interpolated the data, and those models are not really suited for the study of the drawdown areas. So I used my data what I had, calculated what the shoreline would be at the different water levels in reservoir, and then followed other studies about how the hydropower plants influence the water levels in reservoir, what are the drawdown areas, and etc. And it's all in the research paper. But now the more interesting part, I thought how to make this process easier because those areas are really difficult to survey, and with the large hydropower plant reservoir, it's a big task. So I wanted to implement the remote surveying techniques. So basically, for the starters, I used 2 drones in the same area that I had field measurements. So I know that area pretty well. So it's here is presented the flowchart of the entire process, starting from mission planning, data gathering, establishing the ground control points, then the analysis of the data and different techniques. So I will go to those results. So the different flights were made during different water levels, so I can compare the data. The water levels were measured and the ground control points were established, so I can very accurately compare the data. So after that, the gathered data was analyzed with the photogrammetry techniques. And now this is the most interesting part. It's actually using the data that I have gathered. So as I mentioned, I had multispectral and RGB images of that area. That allows for different approaches. So basically, my task was to determine where the water is. And for this task, I used some indexes that are quite commonly used. And this is better than just looking at the picture, because you can train the classification techniques, for example, isoclustering or artificial intelligence algorithms for them to determine, okay, this is water, this is vegetation, this is sand, and etc. And the more reliable the data, the more interesting things you can see, because my main goal was to determine the shorelines in the areas that contain the aquatic macrophytes, the water vegetation, because this is the areas that are most difficult to access and most difficult to survey. So after plentiful analysis, I found the best suiting methods to determine where the water is, and it works like X-ray. I can see it through some vegetation, and I can determine where the water line is, and then compare it when different water levels are in the reservoir, what the drawdown areas are. Yep. So this is a very small scale, because it was like 505 hectares. But I want to use this research in the large scale. So this information is very good data for the training of the algorithms, for the artificial intelligence. So I can use this data for the different data sets. For example, for the satellite data, I can say, okay, I know all the properties of, for example, water vegetation. Now I can train it to find those areas with the data taken from satellites. And of course, the resolution is not that great compared to the drone shots, but still, using this data set that I have, I tried implementing it and had some success, but still more research must be carried out. So final thoughts, yes, it is possible to implement modern research techniques and get quite good results. It's much easier that way. And this is quite important, because this information is really the key for the decision making, because we have quantitative assessments, not just some rules that are made from rule of thumbs, but now we can see how these measures affect on the reservoir, and maybe we can use more. For example, water, maybe less. It's up to debates, but there's a way to actually assess it, and that would be the main point. So thank you for attention. I'm open for some questions, and mostly for maybe some suggestions, because this is my field.